So in this small video, I'm going to show some parts of a nice blueprint made in Eplan. And I think that project managers should walk through everything before delivering to production, because this can cause some delays. Um, I'm not saying that I don't make mistakes. I do make mistakes. But if you are lying down all day in your sofa, you're doing everything perfect, like the pic shows, no mistakes. So let's dive into it. First, there's a lot to be said about switching boards. Uh, Alone, the heat dissipation calculation is a pain in the bottom. Um, in this case, we have passive cooling uh, and no air condition, anything to cool down. I would say intuitively, I don't want this drive unit here. I want them, I want down, like every power electronics in one passive cooling switchboard. As we all know, the hot air is lighter than cold air and creates some nice passive air circulation. So we don't need additional coolers uh, in the future. I mean, yeah, but you still have to calculate. That's that. So let's scroll down a bit. There's some power input, and that's connected to the copper bars, delivering the power to the other equipments. It's okay to have only protection for three phases, man. Yeah, right. Power delivery goes into the copper bars. Okay, but in this case, we have also one phase equipments here and further down, right? So this is not a balance circuit. So the neutral should also be protected. So this is the neutral input and should be protected with some fuse here. So let's get further down. Uh, we have 30 milliamps from earth leakage protection. Um, you have to calculate this with the earth resistance. 300 milliamps earth protection would be intuitive okay. This is a bit low, but anyway, you have to justify your calculations. Further down, okay. This is not good to be seen. Yeah, this is not okay. You can do it, practically works, but we only use one pole protector for the transformer. Um, yeah. One thing a bit suspicious here are the protection numbers here on the transformer protection. I mean, let's see it from the output side, from the low voltage side. We cannot say output input because you can rotate the transformer. So in this case, from the low voltage side, let's do some calculations. We have 7 times 6 amps in worst case scenario times 24 volts. 24 volts, that's the result, it's 1000. And we said ideal machine. What? It's on the limit. Yeah, it's too much on the limit. I mean, I would prefer to have some breathing room for the transformer. Yeah, better this way. Let's look from the high voltage side. Let's use the Ohm's law. Power over voltage. We said perfect machine or ideal machine. 1000 over voltage 330 volts. It will be some sort of 4.3 amps. So with this protection up there, you reach 50%, 60% of the transformer's capacity. Okay, 60%. I mean, 60%. It's the I mean, the efficient point from the transformer. It's okay, but you cannot deliver as much power as you have planned here. I mean, that's not doable. This kind of protection. Yeah. So, going to show you one more small thing. It's 6 amps in the high voltage side from the transformer and rectifier. In this case, it must be, and it is, a switching power rectifier, power electronics, and 6 amps in the low voltage protection. This is not doable. It's not possible. You're not protecting anything. And with a 4 amps power switching uh, uh, delivering, yeah. You have DC to DC converter. I mean, you're not protecting anything. These kind of things must be corrected before you deliver the project to the workers below, to the production. I mean, this is why every project manager should take a walk to every single process um, to minimize the errors. Yeah. More eyes on the project, less errors coming out. Yeah, that's my ideology. Yeah, because everyone makes mistakes, even the project manager.